Alright, so as a review, we're going to be looking at finding angles using trigonometry. So with the finding sides notes, we define the three basic trig ratios: sine of angle A, cosine of angle A, and tangent of angle A. So we're going to use these basic notes to find some angles. Here were the notes for the finding sides that I did last lesson. Okay, and so we have these already, and we label the two sides, the given and the unknown, and that determines which trig ratio to use. And from there we set up the equation. Now we're going to do the same thing today, except we're just going to solve it a bit differently. And here are some examples of solving sides using trigonometry. We've got those, using tangent, using sine, and using cosine. Alright? All examples of finding sides using trigonometry. Okay, so the first thing I'm going to do is look at the perspective from the angle I want to figure out, which is this guy right here. And if I'm at angle A, I look at these two sides here, and I have to label it either opposite, adjacent, or hypotenuse. So these two sides right here, 13 is going to give me the hypotenuse, because it's opposite the right angle, and the 5 is going to give me the opposite. So I label those. And because the two sides are opposite and hypotenuse, that tells me which trig ratio to use. Opposite and hypotenuse is going to be sine. The sine of angle A is when I use opposite and hypotenuse. So I set up my equation leaving the angle out. I don't know what the angle is yet, so it's going to be A. So I write this equation right here, not knowing how many degrees it's going to be. So that says the sine of angle A equals 5 over 13, and I want to find out what angle A is. Now, just like all math functions, like the opposite of times is divided by, and the opposite of plus is minus. Well, this sine ratio has an opposite as well, and it's called inverse sine. So if I want to find the opposite operation of a sine ratio, it's going to be called inverse sine, which is on the calculator as it looks like sine negative 1, or cosine negative 1, or tangent negative 1, which means the inverse function. And these functions up here are the ones we use to find angles. So what we do is we're going to find the inverse sine of 5 over 13. Now right here, if you want to change this to a decimal, you can, but you don't need to. Okay, so we're saying the angle is going to be the inverse sine of 5 over 13. Now, if you don't want to write it as a fraction on your calculator, just write it as 5 divided by 13. And making sure we're in degrees mode, which is the D right there, that gives us our answer in degrees. And I always round it to the nearest whole number because 1/10 of a degree is pretty small. So we'll say 23 degrees. Okay, let's try another one using another trig ratio. So we're going to be using either cosine or tangent for the next one. Alright, so we'll go through a run through of this one. We've got our two sides that are labeled, 17 and 25. Now, where I am from angle B, that's going to be adjacent, and that's going to be hypotenuse. So let's give those the highlighted colors. And from our SOHCAHTOA thing, adjacent and hypotenuse have to do with cosine. So set up the equation. Cosine of angle B equals 17 over 25. Alright, now finally, we do the same thing that we did with the sine ratio. We use inverse cosine to solve for B. Okay, so don't forget to use inverse cosine on the calculator. 17 divided by 25 inverse, and I get about 47 degrees. Now this one, you try labeling this one on your own. And remember, when you label your two sides, we're using these trig ratios right here. And see if you can solve this one yourself. Okay, and if you use tangent, inverse tangent, to solve this one, good job. Now the last thing I'm going to do is just, the question is, what if you're given all three sides of a triangle, and you don't know which trig ratio to use. So with this one, we're given the three sides, and we only need two sides to pick a trig ratio. That's it. So if we were to pick 24 and 26, if we picked those two sides, we get opposite and hypotenuse, which means it would be sine. So D would equal the inverse sine of opposite over hypotenuse. Well, if I pick two other sides, such as 10 and 24, I would get adjacent and opposite. Which trig ratio is that one? So SOHCAHTOA. That's tangent. And that would equal inverse tangent, opposite over adjacent. Or if I picked these two sides, adjacent and hypotenuse, that would be cosine. So it doesn't matter which ones I pick, because I'll get the same answer either way. Now, all of these values equal the same thing, because that angle is not changing and it's not moving. So a good thing to practice is practice all. This should be a -1. Practice, put all these into the calculator, and we'll get the same thing every time. And we all get 67 degrees, of course. Okay?
Yeah.